Now we're looking at a hollow block wall, okay? This is quite common in Ireland, especially in Dublin, but also other parts of the country, or it could represent a mass concrete wall either. So the same principles would apply. What we're showing in this particular wall example here is an internal insulation approach, and it's different to one of the other ones we've shown here insofar as we're using a vapor control layer, which we'll talk about again in a second. All right, so we've got your hollow block here or your mass concrete. In this case we're actually using timber battens to support our insulation, and we've isolated those timber battens from the concrete wall with a damp-proof course here, all right? So this damp-proof course prevents any moisture coming through the concrete and potentially damaging those battens. The battens should ideally be treated timber battens so that there's no risk of deterioration or rotting over time. Okay, now what we've done here then is we've actually insulated between the battens, so that gives us a good piece of insulation, right? But you can appreciate that the timber battens here themselves, even though they're made from wood, which is not a highly conductive material, they would represent a thermal bridge, wouldn't they? So you've got wood, insulation, wood, insulation. So we want to try and reduce that thermal bridge effect, and we can do that by adding another layer of insulation on the inside, and we've done that here through what we call a service cavity, all right? So you can see we've a second layer of insulation here between these horizontal battens. Okay, now one of the things I want you to really appreciate in this design is this vapor control layer. Okay, remember now the inside face of this concrete wall is going to be quite cold, isn't it, on a cold night? And if vapor from the house can make its way through the insulation and hit that cold surface, you could get condensation and mold behind the insulation board, and that wouldn't be a good idea. Okay, so we can use this vapor control layer now. This vapor control layer would be continuous. It's taped to the window, it's taped to the floor, it's connected to the ceiling as well, so it's continuous, in other words, with no breaks in it, and that will dramatically reduce the amount of vapor that can potentially leak from the house in through the insulation. All right, now in order to protect that vapor control layer, these horizontal battens here and this service cavity that we've created will be a big benefit, won't it? So we can put in electrical sockets, we can put in piping, we can put in electrical cables, and none of those penetrate this vapor control layer because it's in this service cavity that we talked about. So this is not a very common approach, but it really is the exemplary approach to retrofitting. You don't have to use this type of board. This is a PIR board. You could use different insulation boards. You know, there's lots of different insulation boards that you can use. So, but the key principle here, which is of notable difference, is that we've got this vapor control layer in order to try and reduce the risk of mold or condensation behind the insulation.